Hello everyone, my name is Jacqueline Arredondo and my presentation is on polychlorinated biphenyls, which I am going to be referring to as PCBs for the rest of my presentation. What are PCBs? In a very simple definition, PCBs are a group of man-made chemicals. All PCBs have a similar basic structure which is made of carbon, hydrogen, and chlorine atoms. These atoms can be combined in different ways to form a total of 209 PCB molecules. Some PCBs can be more harmful than others and are either a solid or an oily liquid that is usually clear and slightly yellow and appears to have no taste or smell. History of PCBs. In 1927, PCBs were first manufactured commercially by the Anniston Ordnance Company in Anniston, Alabama. A few years later, 23 of 24 workers of the plant had acne-like bumps on their faces. Some complained of loss of energy and appetite. In 1947, GE began using PCBs in the manufacture of electrical equipment at their plant on the east shore of the Hudson River. A little later, GE began mixing PCBs with oil in their own formula and began using PCBs at their Hudson plant. In 1979, the EPA issued final regulations banning the manufacture of PCBs after a 3-year phase-out period. EPA rules also gradually ended many industrial uses of PCBs over the next 5 years. And in 1980, U.S. Congress passed a Superfund law that was designed to provide financing for cleanup of the country's major toxic waste sites. PCBs are found in many different things. Before their ban in 1979, PCBs entered the soil, water, and air through manufacturer use. Besides animals like fish and poultry, PCBs are also in microscope oils, electrical appliances like TV and refrigerators, old fluorescent lighting such as light bulbs. And PCBs are also found on a spray that was used for dirt roads. Health effects of PCBs. Studies show that PCBs cause cancer in animals, and the data strongly suggests that PCBs are probable human carcinogens. Studies in animals and humans suggest that long-term exposures to PCBs can suppress the immune system. PCBs are also harmful to the reproductive system. Children born to women who worked with PCBs in factories show decreased birth weight and a significant decrease in gestational age. PCBs have also demonstrated effects on the thyroid hormone levels in animals and humans. Thyroid hormone levels are critical to normal growth and development. Alterations in the thyroid hormone levels may have significant implications for health. Dose and occurrence of health effects. It is difficult to find updated human studies that show dose and occurrence of health effects. EPA's cancer guidelines favor basing dose-response assessments on human studies. However, because PCBs were banned, this altered the effect of PCBs since it lowered exposure humans would have usually been exposed to. Because of this, risk estimates can be derived from animal studies also. An article published in the Toxicological Sciences included a study that was conducted on a series of PCBs to view chronic toxicity and carcinogenicity. This was an animal study that was conducted on 650 male and 650 female rats. These rats were assigned to 11 treatment groups that varied by their sex, weight, and dose. These rats were observed over a 24-month period. Graphs from the study look at the time of exposure to the probability of survival. As you can tell from the graphs, the longer these rats were exposed to PCBs, the probability of survival dropped extremely. It is also important to know that both graphs' probability usually begins to drop significantly after exposure is around 12 months. Exposure. Exposure circumstances are addressed in a certain framework that distinguishes different exposure pathways as lower or higher risk. One of the higher risk and primary route of exposure to PCBs in general population is the consumption of contaminated foods. These foods are contaminated meat such as fish and poultry. Another route of exposure that is seen as a lower risk is occupational exposure. Occupational exposure to PCBs occur mainly through inhalation and dermal routes. Something that I found really interesting was that about 10% of PCBs produced since 1929 still remain in the environment today. With that being said, who is at risk of exposure? Well, the answer is everyone. Small amounts of PCB can be found in almost all outdoor and indoor air, soil, sediments, surface water, and animals. Whether you live near a hazardous waste site, are swimming in surface water, ingesting contaminated foods, or simply working in a factory, exposures to PCBs still linger. So what methods are being used to manage these risks? Other than the ban of 1979, agencies have provided different recommendations and regulations to protect public health. The Food and Drug Administration has set residue limits for PCBs in various foods to protect from harmful health effects. The Occupational Safety and Health Administration regulates that workers not be exposed to inhalation over a period of 8 hours for 5 days per week. The National Institute for Occupational Safety and Health recommends that workers not breathe air containing 42 or 54% chlorine PCB levels higher than 1 microgram per cubic meter of air for a 10-hour workday or a 10-hour work week. And the EPA requires that industries tell the National Response Center each time 1 pound or more of PCBs have been released into the environment. And last but not least, my last slide are my references.